Listen to part of a lecture in an astronomy class.
Saturn's rings have always baffled astronomers. Until about 30 years ago, we thought the rings were composed of particles of ice and rock that were left over from Saturn's formation. Extra material that never managed to form a coalesce into a moon. As you know, it's believed that Saturn and all the planets in our solar system coalesced from a swirling cloud of gas some 4.8 billion years ago. However, if the rings are made of leftovers from that process, then they'd also be about 4.8 billion years old. The problem is that anything gathering space dust for that long would certainly have darkened by now. But Saturn's rings, most of them anyway, are pristine, so bright and shiny that they make Saturn the jewel of the solar system. So the hypothesis that the rings are just made of material left over from the time of planetary formation, that hypothesis must be wrong. Saturn's rings are much younger than the planet itself. They may have formed only a few 100 million years ago, around the time the earliest dinosaurs lived on Earth. We realize now that the ring particles, which range in size from microscopic dust to boulders bigger than large houses, well, a lot of these particles are eventually lost. We believe they gradually spiral down out of the rings and into the planet's atmosphere. This occurs as a result of the planet's gravity, and also because of the effects of its magnetic field. Now, if material from Saturn's rings is being lost, and nothing new is added from time to time, the rings would be disappearing. But that's not happening. So somehow, there must be new material feeding the ring system. Question is, where's this new material coming from? So, we're back to square one. But instead of asking how did the rings form, we should be asking, anyone? Beth?
How do the rings form?
How do the rings form? Because they're apparently replenishing themselves somehow. Okay, here's one possibility. The moons, the dozens of moons that orbit Saturn, are providing raw material for the rings. A moon in a system as complex as Saturn's, and Saturn has at least 49 known moons, which vary tremendously in size and shape. A moon in such a complex system is not only affected by the gravitational force of the planet, but also by that of the other moons.
So the planet may be pulling a moon one way, and other moons may be pulling it other ways?
Exactly. Such forces could actually alter a moon's orbit, and as a result, there might be a collision. One moon might crash into another, and the debris from that collision could become part of the rings. Then there are tidal forces. A moon might get too close to the planet and get broken apart by Saturn's tidal forces.
Excuse me, you mean tidal forces like high tide and low tide on the oceans?
Well, by tidal force, I'm referring to the gravitational pull of Saturn on its moons. In the mid-1800s, a French scientist named Edouard Roche was studying the effects of a planet's tidal forces on its moons. Roche was able to show mathematically that if one celestial body, say a moon, if it passes too close to another, say a planet, that has a gravitational force stronger than the force of self-attraction that holds the moon together, well, that first body, that moon, it'd be ripped apart. We call the distance at which this happens the Roche limit. So if one of Saturn's moons reaches the Roche limit of the planet, or even a larger moon, it would disintegrate, be torn apart, and thus add more material to the ring system. And there's another way new material might be added to Saturn's rings, an asteroid crashing into one of the moons. This hypothesis is supported by the fact that some of the many rings are a bit reddish in color. Yes, George?
I'm sorry, I don't follow the logic.
Well, this reddish coloration suggests the presence of complex organic molecules, carbon-based molecules, mixed in with the water ice. Remember, the rest of Saturn's rings are made almost entirely of water ice, and none of Saturn's moons is red. But asteroids could be, and thus could end up contributing to the ring system the kind of carbon-based molecules we're talking about.